Hello, and welcome back to a video series on MAT 1033 Intermediate Algebra. My name's Sean Perry. This is video number 40 in the series, Factoring Monic Trinomials. So first off, let's clarify some of the terms from the title. A trinomial is a polynomial that has three terms. A monic polynomial is one whose leading coefficient is 1. The leading coefficient, or the leading term, is the monomial that has the highest degree. So the variable with the largest exponent, its coefficient needs to be 1, and then you're dealing with a monic polynomial. You see the word mono sort of in there, indicating a 1. And we're going to be focusing exclusively on quadratic trinomials. That is to say, the biggest power is a 2, or a square. And so if you put all that together, this is going to be the main character of our video. It's going to be something that looks like 1 x squared plus something x plus something. So our goal is going to be to factor this. That is to say, we're going to take a polynomial that looks like this, and we're going to write it as a product of two other polynomials. Now, I've used some funny symbols here. This is an alpha and a beta, but they're just standing in for numbers. Let's take a look at the end result. Let's start with the factored form and see what that's going to mean alpha and beta have to look like, and then we can get rid of the alpha and beta and just look at that. So let's say I started with the factored version, x plus something times x plus something else, maybe. Okay, so what would the middle term have to look like in terms of this b and d? Now, the first term, they're both going to have to be x. That's because it's monic. That's because this first one has to be a 1, so I need two things to multiply and give me a 1. And as long as we're just talking about positive whole numbers here, the only options we have are for these coefficients to be 1 as well. We can't have 2.5 here, or we're not really going to be in the right situation. Or rather, we would always be able to rewrite that in terms of this situation. I can sort of show that in a later video, but for right now, let's just take for granted that these two leading terms here are going to have to be 1x. And when we FOIL that, we get our 1x squared. And then what about the middle and last terms? So these are going to be really our focus of this video, are the middle and the last terms. Notice that the middle term is the sum of these two b and d's, because we'd have a bx and a dx, and like terms would make that b plus dx. And then the last term is b times d. Again, this is all the logic of FOILing here, plus the like term step. So I have a product of those two numbers, b and d, that gives me my last, and a sum that gives me my middle. So to reiterate, we need, if the original is monic, that is to say 1x squared is the leading term, then the two x's in our factored form also have to have 1's in front of them. The middle term was b plus d, and the last term is b times d. So there's going to be a relationship between products and sums that we're going to have to investigate. So comparing that to our original notation where we had an alpha and beta, the middle term was alpha, and alpha has to be the sum of those two numbers from the factored form. So to factor something that looks like x squared plus something x plus something, we need this last term to have factors, that is to say two numbers that multiply to be it, that sum to be the middle term. And that brings us to our first critical notes. Copy this down, show it to me later. If I am going to factor something that looks like x squared plus b plus d, x, plus b times d, I can do that by using FOILing in reverse. We get the following, x plus b times x plus d. This is going to be the pattern that holds for factoring all monic trinomials that we're going to be looking at. So let's do a numerical example. Let's say I wanted to factor x squared plus 7x plus 12. We need to know what numbers will multiply to give 12 and add up to give 7. So what we could do is list the factors of 12. 12 and 1, 6 and 2, 4 and 3. All of these multiply to give 12. And the sums of those things, well, the sum of the first set of factors is 13, then 8, and then 7. Okay, 7 is the middle term, so these two, 4 and 3, these are what we want. We see that middle term, and so we are going to take these two as our factors. We write x plus 4, parentheses, times x plus 3 in parentheses. And that, if you want to check it by FOILing it out, right, we'd get x squared here. We'd get 4x plus 3x, that's 7x. And the last term would be 4 times 3, that's 12. So this is the factored form of this monic trinomial. And truly, that's all we need, as long as you understand how adding and subtracting negatives and multiplying negatives work. But since that seems to usually be the part that gives everybody the most trouble, perhaps we need to go in a little bit more detail about what happens when b or d or both are negative. So let's look at this series of examples. I've kept the numbers the same, 3's and 2's, and all I've really done is I've changed what the signs are inside of these factored forms. And here I've written things foiled out. So let's think about the patterns that we're seeing here. We have all pluses, we have a plus and a minus turning into a plus and a minus, but then we have something weird. We have a minus and a plus turning into two minuses? Yes, foil it out and check it for yourself. And same thing here, we have something weird. A minus and a minus, well, the negative 3 times negative 2, that's positive 6. So what's really going on here? How can we sort of ingest this pattern and also relate it to the middle terms? Notice we have a positive 5 or a negative 5. We have a positive 1 and a negative 1. So there's really two patterns that you need to be aware of here. Two different cases, I should say, and two patterns. If the signs of b and d match, as in the case with 1 and 4, then the last term, b times d, is positive, right? If b and d are both positive, bd is positive. And if b and d are both negative, b times d is also positive. Then the middle term, if I add two positives, or if I add two negatives, it looks like a sum of those numbers whose sign is going to be the same as that sign of the two numbers. And again, they have the same sign, so if they're both positive, their sum is positive. If they're both negative, then their sum is negative. Let's look back at 1 and 4 and see that happening, right? Here's 1, here's 4. Notice the signs match, and with that same sign, we wind up with a positive term in our last place. And we wind up with the sum of 2 and 3 in the middle place. And we wind up with, if they're negative, this middle term is negative. And if they're positive, this middle term is positive. It still looks like they're sum, but it is taking on the sign that these two share, either negative or positive. What about the other two? Well, if the signs of b and d don't match, one's positive, the other's negative, like in case 2 and 3, then the last term is going to be negative. That's because a negative times a positive or a positive times a negative is negative. And the middle term, b plus d, looks like a difference. That's because a positive plus a negative is going to take the difference of those two numbers. Now, the sign of a positive plus a negative depends on who's bigger. If the negative is bigger, the sum is going to be negative. If the negative is smaller, the sum is going to be positive. And let's compare that to what we see in 2 and 3. So here's 2 and 3. Here 3 is bigger. And so when we FOIL, we have 3x minus 2x is the difference, positive 1, right? That's really 3 plus negative 2. So it is really a sum. It does follow the pattern we already looked at, yes. But how should we think of that? 3 plus negative 2 or 3 minus 2, right? And here we have minus 3 and positive 2. That gives me a middle term of negative 3 plus positive 2. That's negative 1. It's the difference of 3 and 2, and the negative sign comes around because the bigger quantity, 3, was negative. And let's now pay attention to the 6, right? 6 is negative in both cases because that's negative 2 times positive 3 or negative 3 times positive 2. Both of those give negative 6. Now, rather than trying to memorize all of these cases, or even worse, just like guessing and then checking to see like that you get what you want, what we want is an algorithm. We want a series of questions and a series of moves that gets us the right answer. So let's see what an algorithm like that would look like in an example. Here I have x squared plus 3x minus 4. The first thing we want to do is we want to set up parentheses. This is a square, so we're going to need 2 parentheses. Then let's add some x's to these parentheses. We can just put them right up front because we know we're going to need 2 x's with 1's up front, their coefficients are 1's, to give me this x squared with a coefficient of 1. So we can fill in our x's. Now I know at least one of the middle terms is going to be positive because we're going to add them up to get positive 3. And because of that, we can just drop down that first term from the positive 3 into the first parentheses here. So we had plus 3x. We want to drop that plus right into place. And now we want to use a little bit of foiling logic. Now we want to say, well, okay, what should the second term be, right? I know when I FOIL and I take my last times my last here. What are these two going to multiply to be? Well, they're going to be -4. And specifically, they're going to be a negative number. So I need a positive number times what gives me this negative number. Well, that's going to mean we need a negative in this second position. So we know this. We know all of this setup without even looking at the 3 and the 4. The 3 and the 4 didn't even matter. Just looking at the pluses and the minuses, I can figure out I need at least one plus, and its companion has to be a minus so that I get these signs when I FOIL. That's what I mean by not memorizing those patterns. Figure them out using your foiling logic. Now, because these signs are different, we notice that it's a positive and a negative. Those are different. So I need a difference of factors to give me the middle term. The middle term was a 3. I need factors of 4 with a difference of 3. That's going to be 4 and 1. 4 and 1 have a difference of 3. Now, because the middle term was a positive, we can always just take our biggest factor and put it right here. If they match, don't worry about where you're putting it. But if they are different, like 4 and 1, we put the bigger one right here. And that means the smaller of the two, or the smallest one, is going to go right here. So we put a 4 in the first spot with the plus sign, and we put a 1 next to the minus. And we're done. That's the factored version of x squared plus 3x minus 4. It's x plus 4 times x minus 1. How can you check your work? You can FOIL. Just take it back a step. If you do x times x, it's x squared. If you do x times minus 1, you get minus 1x. If you do 4 times x, you get 4x. And if you do 4 times minus 1, you get minus 4. Put it all together, and what do you got? You got x squared plus 3x minus 4. That is what we started with. So this is the correct factorization. Now, let's record that with a little bit. I gave a lot of commentary there. Let's record that a bit shorter as some more critical notes. Here is a critical example. Copy this down for your notes. How did we factor x squared plus 3x minus 4? First, we set up parentheses. Then we dropped an x into the first places. Then we put the middle sign, a plus, down into this first term. The second sign needs to FOIL to give me a minus in this position, so this must be a minus sign that goes here. Then we notice that these are different, a plus and a minus, two different signs. So we are looking for a difference of factors of the last term that give the middle term. That was 4 and 1 with a difference of 3. We put the biggest one next to the sign that we dropped down from the middle term, and we put the smallest one right here, and we're done. That's the factorization that we were looking for. Okay, so obviously when you show your work, I don't need you to write down 6 different parentheses here, just changing one thing at a time. That's just something I did so that you guys would see the order that I did my steps in. If I just write it all down at once, it's sort of hard to see the order that I do things in. And the order kind of matters here, or in the sense that I'm asking a particular series of questions, and those questions come in a certain order. Okay, let's do another example. Let's say I wanted to factor x squared minus 18x plus 80. Okay, first we want to write down some parentheses and put x's in the leading places. We drop this sign down and we say, what times this negative is going to give me a positive in my last place? Well, a negative times a negative gives me a positive in the last place. So now look, we filled up everything, including the signs, except for these last two terms. And we note that those signs are the same. Same sign sum. We are looking for a sum of factors, which will give me the middle term. So what factors of 80 have a sum of 18? Going down my list of factors of 80, I see that I get to 8 and 10, and they have a sum of 18. So I put the 10 in the first pot. Actually, it really doesn't matter if the signs match, right? But because multiplication is commutative, but I just get in the habit of putting the bigger one first and the smaller one second. And that is our factorization, right? We have that x squared minus 18x plus 80 is equal to x minus 10 times x minus 8. And you could FOIL this out and make sure that that is the case. The main difference here was that when we looked at the signs involved, they were the same, and so we needed a sum to give the factors of the middle term. We say same sign sum, different signs difference. So here's some more critical notes. Copy this down too. These are the sign patterns that you're going to see when factoring trinomials. I've put boxes here because we're not focused on those numbers. They could be whatever. What we're focused on in this pattern is the signs. If I have all pluses, then we're going to get all pluses. If the first one's a minus and the second one is a plus, we have at least one minus, and then the other one must be a minus sign so that they FOIL to give a plus. These are the same signs. Same sign sum. We're looking for a sum of factors of the last that give the middle term. If we have instead a different order here, it makes all the difference in the world. We have a plus and then a minus. We're going to need at least one plus because there's a middle term that's a plus here. And then what will multiply by that plus to give me a minus in the last place? We need a minus here. Likewise, if I have both minuses, I have at least one minus, so we can put that here. And then foiling has to give a minus in this position, which means this one must be a plus. In both of these two cases, we have different signs. Different signs, difference. We're looking for a difference of factors of the last, which give us the middle term, the middle coefficient. So these are your two big broad cases and the sign patterns that get you there. But that being said, I don't want you to memorize this box. What I want you to do is follow the algorithm of setting up the parentheses and then ask yourself about how do I FOIL this to get the signs that I want using the sign rules for multiplication. Positive times positive is a positive, negative times negative is a positive, and positive times negative or negative times positive give you a negative. All right, time for some practical exercises. This is your praxis for the day. I want you to factor these polynomials. So pause the video at this time and give each one of these a shot. Okay, let's see how you did. For the first one, I set up my parentheses. Then I say I need an x in each first position because this is a monic trinomial. There's a plus right here, so I put a plus right here. And a plus times what gives me a plus? Another plus. These signs are the same, so I'm looking for factors of 8 that sum to be 6. That's 4 and 2, and we're done. Next, parentheses, parentheses. I need an x and an x. The first term is negative, so I can put a negative here. And a negative times what gives me a positive? A negative times a negative gives me a positive. So I need factors of 48, which sum to be 14, because these signs are the same. Well, that's going to be, thinking about it for a moment, 8 and 6. 8 times 6 is 48, and 8 plus 6 is 14. There we have it. On to the next one. Parentheses, parentheses. I put an x in the first places, and then I copy this sign. There's a middle term of positive, so I put a positive there. And a positive times what is a negative? A negative. And positive times a negative will give me this negative. So these signs are different. So now I'm looking for a difference of factors of 36 that gives me 9. And thinking about it for a moment, 9 times 4, no, that's a difference of 5. What about 3 times 12? So I can put my bigger term first, 12, my smaller term, 3, in the second position, and this will FOIL correctly. X times x is x squared, 12x minus 3x is 9x positive, and 12 times minus 3 is minus 36. All right, we set up parentheses. We put an x in each term. We have a minus sign for the middle term. We copy it over. And a minus times what is a minus? A minus times a plus is a minus. So now I need factors of 30 with a different signs difference of 7. Well, that's going to be 10 for our bigger one, and 3. Those have a product of 30 and a difference of 7. You could FOIL this out and check it. That's our answer. Okay, set up parentheses, put an x and an x. I need a positive to go here. A positive times a positive will give me a positive. And then I need factors of 9 with a sum of 6. Well, that's 3 and 3. Now, those match, and this is good enough, although there's a simpler, or I should say shorter way that we could write it, because we have something times itself. We could write this as x plus 3 squared. Okay, both valid ways of writing that. Now, let's go on to this last one. Perhaps this might throw some of you for a loop, but that's because we're missing a middle term. But a missing middle term just means that it has 0 for its coefficient. So what I'm looking for here is actually the following. Now, if you were stumped on it before, maybe think about it again. Pause the video if you didn't get it, and think about this. What would give me a 0 for this middle term? We would set up parentheses, right? And we would say to ourselves, I need an x and an x. I need a positive, and a positive times something gives me this negative. So now, can you think about it? This is different signs difference. What factors of 9 have a difference of 0? Well, just like before where we had 3 and 3 have a sum of 6, 3 and 3 have a difference of 0. So I could put a 3 here and a 3 here, and this would cancel. This would cancel the middle term. We'd have a positive 3 for one middle term, and we'd have a minus 3 for the other middle term, and that would give us a 0x here. We can't write this as a square because these two terms are really different. But what we have now is a way of writing things that look like the difference of two squares as a product. We'll talk more about that one a lot when we talk about our special formulas for factoring, because you're going to be able to recognize this pattern soon enough and just go straight into this factorization. This is called the difference of squares. All right, that's it for this video. Thank you very much for your patience and have a great day. Good luck with your studies, and I'll see you in the next one.